and Copper Alloy Rod Production and Usage webinar sponsored by ABC Metals, Inc. We are pleased to welcome back our special guest presenter, Jim Mickle, Manager, Technical Services for the Copper Development Association. Last year, as CAPSA prepared for its first ever training event, we partnered with the CDA for 3 metallurgy webinars. These webinars provided background context for the presentations that event attendees would receive on site. We're happy to partner with Jim and the CDA again this year to present today's webinar as context for our upcoming Service Center training event at Mueller Brass Company on September 17th. Jim has worked in the metals and corrosion industry since 1973, including the copper and brass, zinc, and steel industries. He's held positions in research and development, technical service, product development, market development, and sales development. As well, he's operated his own metallurgical consulting business. Additionally, Jim taught metallurgy courses for ASM International for 10 years, and he joined the Copper Development Association in January 2007. He's going to go through the presentation. We'll have a Q&A at the end. So if you think of a question during his presentation and you want to go ahead and submit it on the questions tab, feel free to do so. He will actually answer those at the end of the presentation. We'll also have a recording of the webinar, and we'll have that available on CAPSA's website and our YouTube channel. And we'll also have a copy of the slides. So you'll receive a survey 1 hour after the presentation ends. Once you complete the survey, there will be a link. You can download the slides for future reference. Without further ado, I turn the presentation over to Jim Mickle.
Thank you. Can you see my slides?
I'm switching it over right now, so okay.
Can you see that?
The preview screen. Did you, Jim? Did you accept the little pop-up button that you should have seen?
Yes, I think I did. Show my screen.
Yes.
Is this the screen now?
Yep, first slide just popped up.
Okay, I'm sorry for the production delay here. I am speaking today on copper and copper alloy rod production and usage. And as Carly pointed out, this is prior to the site visitation at Mueller Industries in Port Huron, Michigan on the 17th. Hopefully this will be a good introduction for that. So let's see what we do. Okay, I just wanted to give a slight overview of the presentation. I'm going to talk one slide on U.S. consumption in 2013 and the markets. Then we're going to talk about copper rod production in wheelcasting, upcasting, so different types of production. Then we'll talk about brass rod production or copper alloy rod production, primarily or essentially extrusion. And various parts of that. We'll have a chart on copper and brass alloys that are normally extruded and examples of usage and shapes. And then we'll have a discussion on outputs that are affecting this area. So let me start with the slide here, which we actually is the last full year. Obviously, this is 2014. We don't have a full year of 2014. Last full year of U.S. consumption that's available for the copper and copper market is 2013, last year. As you see at the lower left, total of all stocks in all these areas is 5.13 pounds. Now this is segmented, and it's highlighted rod, bar, and mechanical wire, yellow box, 14%, 7 billion pounds. That's 700 million pounds. However, we have another brown segment of this pie chart, wire and cable, 53%. That's a little over half, 5.13 billion pounds, or about 2 billion pounds is in wire and cable. That's produced by rod production, and I'll talk about that first. So there's a lot of copper and copper alloy materials that are produced in rod form, and then down the line they're made various products. Okay, and generally in copper rod production, this is pure copper now, you have a couple different major production techniques: wheelcasting, upcasting, and there are a couple other production techniques. I'll touch on those. I've segmented this copper rod production process in here you see, and let me back up. Since this is primarily just copper materials, pure copper, because it's going into wire and cable, you use cathode. It has to be a very pure material that enhances the conductivity of the material, and you want conductivity to be as high as possible. So you load cathode into the melting furnace. It's shown as a shaft furnace here, and then it proceeds into various launders or metal holding systems. The skimming basin to take off any problems or top skims, a holding furnace, and a lower launder. This then feeds into a casting system. The casting system in this instance, and in many instances, is part of it is a pouring pot or a final melt holding ladle where you settle out of as a molten stream into the casting wheel. There are a lot of different types of wheel casters. There's a number of manufacturers of wheel casters. Now, it's poured in there as a liquid. It traverses around the length of the wheel, and in the extraction process, up as a solidified bar, very hot material, and it's sent through the pinch rolls. It's very important in the wheel caster the cooling sprays, the water and other systems that produce solidified bar work properly. Otherwise, you're going to get improper cooling. The copper bar will not. Everything has to work right. Another point about these wheel casters is you don't produce a round rod immediately. You produce a bar, as it says, and it usually is a trapezoidal, or two parallel sides and two sides that are not parallel but angled. I don't have a drawing of trapezoidal. And as you go further in the production, the copper bar traverses through extractor pinch rolls. It can be cut off into sections and or continuously processed as you go through this production process that will continue in the next slide as well. There's bar prep equipment in case you need to clean the surface in any way before you roll it down into further processing. Well, in this particular processing scheme I picked up, you have various sprays, run mills, and a variety of finish mills. You'll take the trapezoidal shaped bar in progressively, still very, very hot, and so you're hot rolling, and you roll this down progressively to a copper rod at the end. So you're producing a round rod of some certain diameter as it comes out. You're making a tremendously different shape from beginning to end in this process. Now, you definitely want a round rod, but it's more efficient in the wheel casting production to produce a trapezoidal shape. Once the rod is extracted or it is a rod, round rod of whatever diameter, it then has to be cleaned because it's been processed, hot processed. You develop a variety of surface oxides that could be a problem later on. You have to clean that off. Pickling is a process, as many of you know, that is added and various rinses progressively cleaning the acid off. So the acid cleans the oxides off. The oxide or the acid is then rinsed off progressively by a water wash system and wiped using an air wipe system to dry it so that there's no further oxidation. Once you get past that, you want to protect the rod, and in this particular product scheme, they're not producing straight cut lengths. They're producing a coil of rod. So in this, they waxed it. Other places, you may put a slight oil on it. In any event, it's coiled, compressed, wrapped, put in storage, and then as the coils are gathered, the coils then are shipped out to a processing plant which further processes it into wire. And these are electrical wires. The other production process techniques vary mostly in how the rod is originally formed. Here is an upcasting technique. There's several of them. It's a dip forming process. You have a starter or seed rod, and then you progressively pull that through a cooling chamber and over a roll, and it's rolled down in a variety of ways and cleaned and then coiled up or cut into lengths. This is primarily dip forming or dipping process. Upcasting, this is called. There's another version of this which I don't have an illustration on, but this particular process is quite old, even though, in relatively speaking, all these upcasting or wheel casting processes were developed from the 20th century, mid-20th century until the end of the 20th century, Wheelcasting being, I believe, the oldest. I've worked in plants which do both of these things. For the wheelcasting is a faster production process. Well, what do we make out of all these product or materials that come off the wheelcaster, the upcaster? Primarily, that's the 53% of the usage diagram is copper and mildly copper alloy rod, and it turns into wire. Sometimes it turns into very, very fine wire. And having been through one of these wheelcasting plants with the samples of wire or materials that are produced from those at the end, you can have all these different types of cables that are the output. Some of them are finer than your human hair as far as the wire that is produced. Bundled, packaged, wrapped, or encased in plastic, produced in multiple bundles in cable and wire, go into your house, into factories, production equipment, into the streets under the city, under your town, into machinery. So these are all kinds of pure, very high contact material, usually 100 to 1 or 102% IACS conductivity. Okay, so this, again, is not for, but it of the copper and alloys production rod and wire form. What you look at a good bit at copper rod production at Portland will be the brass materials, primarily produced by an extrusion process, which is quite different. And once we go through this, you'll note the differences. When at the beginning of the copper rod production, there was no scrap generally. The raw material that was input was cathode, pure material. It had been produced in a refinery, copper refinery, and it was essentially 99.99% pure copper. In this instance, you start with scrap as input material. It is sweetened in the furnace and after evaluation by the metallurgy department at the plant to determine, is it on composition, and are there too many impurities, or are there impurities just right? They will sweeten it with various components, cathode and pure zinc or other things as needed to bring it up to the compositional parameters. Then it will go through casting. Then you'll go through various extrusion processes. It'll go through finishing and testing. Testing is integral here, as it is in all processes. Packaging, and then I'll show you a few examples. Well, this is an example of some brass chips or scrap materials that can come into a process plant. The recycling here is very important. Many of these plants bring in qualified scrap and evaluate what is coming in the qualified scrap. They get in truckload after truckload, and they have contracts with not only scrap dealers, but companies that use the rod and make products out of it, such as screw products, screw machine products, and or other things, to provide scrap back to the plant. This, they know, is then an alloy that they can use in remelting. So this material is loaded, and it would have come in a truck or baled in various forms. Here are some chips that were loaded in using a conveyor. These probably were processed chips from screw machine turnings, etc., etc. Again, brass. Composition can be adjusted once you get into the melt furnace and have everything in the molten state. Well, now, this is an example, not necessarily the one you're going to see if you're going to the tour of a casting furnace. This is fed by most likely an electric arc furnace where the melting takes place, where the evaluation takes place of whether the composition is correct. The metallurgy department at the plant makes a very pointed exercise of going and evaluating the scrap before it is put in the melting furnace, evaluating the melt after it is fully molten in the furnace, and then before it's poured like it is being here, it will be reevaluated at this stage to make sure that the if you're making brass, that the zinc content is correct, that the copper content is correct, that other parameters are on target, that you're meeting the ASTM specifications for composition, and only at that point will the material be cast or poured into a cast structure. The output many times are what's called logs, or round material. Now this feeds into the extrusion process. These logs, it seems funny, but in one committee that I work on, I deal with some people from the forest products area, and their logs are certainly different than these logs, but they're both round. That's why they're called logs. These are produced in long, continuous cast product, and obviously you see that it's cooling down the further out of the furnace or the casting structure it makes it. These will then be cut off, generally, into a shorter pieces, rounds, called billets. And these billets are then processed in various ways, and I'll go into that in a minute. This just shows you a lot of the equipment in a rod line, but the billets are generally the raw material that goes into the pieces of equipment. And you're getting into extrusion. Here's an extrusion piece of equipment. Well, you can't see anything here. It's all covered up. You're not seeing anything, output or anything. It's just a piece of equipment. That's partly what you'll see at the plant. The output will be rods, either in cut length, in various shapes, various cross-sectional parameters, or you'll get extruded rods, and then they'll coil them up. This will be the output. Now this will go to a further processor of material that wants a long continuous input material. And in the rod, or the, let me back up. In the previous slide, you have cut lengths. There are some pieces of equipment, some that make parts, pieces, screws, nuts, bolts, that the machinery uses an input series of rods and or various cross-sectional pieces, but they're all cut length. So you have to know, or the customer will tell and specify exactly what they need as input material for their process. So there's different outputs. Okay, so here we have the two different outputs, the coiled and or the cut length. Well, let's go through what the extrusion process really does. This section, cross-sectional diagram of an extrusion press. You'll be able to see some of this or view some of this at the tour. However, if you look at this, it's basically something that pushes a material, and you see the billet is in the center there, and the output is a rod or of various cross-sectional characteristic coming out of the machine to the right. But pushing is a ram, if you see that, and behind that is a hydraulic pressure or hydraulic press. It takes a lot of effort to turn a big billet and push that material through a die, which gives it its shape, into an extruded piece. Now the billet, before it's extruded, is heated. It's heated to a predetermined temperature and then put in the extrusion press. If you're not at the proper temperature and the proper temperature isn't maintained during the extrusion process, you're not going to get the proper flow of the material through the die. It will cause difficulties in extrusion. The press will have at a greater, with greater effort, and you're going to probably have quality problems in the material if you're not at the right temperature, if you're not at the right speed. Another thing, the die, which gives the shape of the output material, output extrusion, must be kept properly maintained, sharp, clean, can't have difficulties in the opening, or you're not going to get a proper extrusion material. The extruded rod shape will have chatter on the surface, quality issues. Well, okay, let's back up a little bit. What is it? And I explained extrusion, but you can do extrusion, and I'm going through this much faster than I thought. The extrusion process can be different for different things, and it can be done in different ways. There's illustration A here is a direct extrusion. That's where you push it from one end and it comes out directly opposite. You're pushed through the die, you're getting the shape, and you're cutting it off or picking it up at that end and running it out. illustration B is indirect extrusion. You're pushing from the left in this instance, and the billet is in the middle, but you're on the right, if you will. You're coming out on the left as well. So the press equipment has to be hollow. You're getting an indirect extrusion. It's coming back at you. In the other two illustrations, C and D are illustrations of tube extrusion from a hollow billet. And you can produce a hollow billet in different ways. C is direct extrusion. We're using a hollow billet. Of course, you're using a rod in the center of the billet that has pierced it. Therefore, you're producing a tube anyway, but the orifice produces a certain size. On D, the tube extrusion from a solid billet, where you're piercing it as you're going along. These are both methods. They can be used. You can note that the extrusion press in many cases can be the same. It's the ram and other equipment that may be different. So you may want to be careful when you visit, or if you are going to visit Port Huron, to see what the process is, ask the questions, and it'll be interesting. Let's go through this diagrammatically. This is a very simplistic way of looking at extrusion and processing of copper alloys for production of rod and or shapes. If you go, you have to, as I said, you have to preheat the billet. The billet then is placed in the extrusion machine or press where the die is located. The die is critical. The die is, well, everything's critical, but the die is very important, and the temperature of the preheated billet is very important to get a good extrusion. In this instance, you're producing a coil of rod. Once, and again, this is a hot process. So in the processing, once you're out of the die into the air of the plant or the atmosphere of the plant, you're going to produce an oxide on the surface. The oxide has to be cleaned off, or you can't process it properly in the future down the line, or you're going to have a problem. So you have to pickle it. Pickling, again, is an acid cleaning of the surface. Again, that's, you wash it with acid and then you rinse it with water progressively until the acid is completely gone, and you dry it. Then you take this and it either goes as a coil or it goes to a cutting line. In either sense, you go through a testing phase. A lot of times this is eddy current testing. You're testing for discontinuities in the rod or piece that are internal, that could cause issues later on. If you have too much internal problems, the quality of the downline product will not be quite right. You can process the material after testing to draw it down further. You can cut it into lengths. You can straighten it, which is a very common thing, not only in strip sheet or plate, but in rod. You can, again, like I said, make coils. or you can make cut lengths. Now, the output there is dependent again upon the customer. I want to go to basic extrusion. Every time you brush your teeth and squeeze a toothpaste tube, you're doing basic extrusion. You don't have to heat it up, you don't have to do anything because the material in the toothpaste tube, the toothpaste, is at the proper temperature, room temperature. Doesn't need any warming. However, if you look at the tube on the right, which is Kids Sparkle Crest with Shapes, you are actually squeezing it shape. Every time you brush your teeth, hopefully morning and night, you're doing extrusion, and you didn't even know it. This is the most basic illustration I can give. Anyway, what happens once you are doing the extrusion? What can you make? You can make all kinds of things. Here are a wide variety of shapes that can be extruded in these processes. You have round rods, you have square rods, you have hex rods, you have rectangular rods, you have channels, you have ones with holes in it. You have, as on the far right, you have ones in a very specific shape for a very specific use, which that you may not even know. It's the downline customer that has asked for this shape to produce a final product, and we'll be using it, machining it, cutting it, shaping it into the absolute final product. So there's lots of things that can be done, and it does all dependent upon the alloy and the die. The die in this case is critical. Again, here's some extruded shapes. You can get two pieces to make a lap joint or an interlocking joint or a dovetail joint or a spline type joint. All these are extruded parts that can be made and then interconnected or used in various ways. Again, here's a wide variety of shapes. These are mostly brass, but they can be varieties of brass alloys or copper alloys. And if you look at the different shapes, you can't necessarily know what they're being used for intuitively by looking at them. Sometimes you discover something that you have purchased is made from an extruded shape, and you didn't even realize it. Other extruded shapes end up primarily rods and other things as screws, bolts, and fasteners, and those rods and those wires and those pieces that are shipped to those fabricating companies end up being made into all these different parts and pieces. You would never know that these were started out as extruded pieces. Now, in the upper left, the nails, those are primarily made out of wire or a very thin rod that is cold-headed, but the screws and the bolts, they're all machined into shape primarily. This is a good example of cross-section of things that you look at and, oh, that is made out of something that was made in these plants. So in this instance, when it's machined, you end up with all those cuttings, turnings, and extraneous materials coming off that is then fed back into the plant as scrap. We also have extrusions such as these, which are in a fancy finished shape, which you may not even think is made in that form. Here you see railings of various types. Obviously, when you get to the finial part or the end of the railing, those pieces are primarily cast, and then they're attached to the straight part of the railing, which is extruded into shape. It's much more efficient that way, and it produces a very nice, good-looking railing. And these are some examples thereof. Some in houses, some in commercial establishments, some outside, some inside. Here's standard shapes. You have hex in various sizes, rounds in various sizes. You can get squares. Here's bundles of brass in various shapes, sizes, cross-sectional shapes, some of them big, some of them small, all of them usable and all of them of necessity for the marketplace that is being serviced. Again, copper, or copper, mostly copper alloys in this instance, but they could be a red brass. And this is a very interesting slide. I came across this. I thought it would be interesting. On, you see the items that are extruded, which are in an unusual shape as far as cross-section. But once they are extruded in that unusual shape, bent or T-shape, various others, modified rounds, they then are machined into the final piece and then put in a bin to be tested and evaluated and used in the final assembly. So this is an example where a very sophisticated, very custom type shape is developed and then used for a final part which is not readily available to your thoughts in looking at the bar. Very interesting. I find it very fascinating. Here's a sample chart of copper alloys that are commonly extruded. It can vary from pure copper, red brass, munce, forging brass, architectural bronzes, naval brass, aluminum brasses, copper nickels, high silicon bronzes. These are just examples. There's a wide variety of alloys that are not on this chart that are also extruded. I did not put the alloy numbers on these, but there are alloy numbers that go with all of these, UNS numbers. There's a wide variety, like I say, of alloys that are utilized for their ability to be extruded. Now, take a look at this chart. In the middle, there's a column called suitable extrusion temperature in degrees Fahrenheit. You'll note that the extrusion temperatures are a range. You can't just have one number. There may be a particular smaller range for certain presses, extrusion presses that is used. But each alloy has a different suitable extrusion temperature range. This is of interest and importance. Obviously, say for example, naval brass, which is a lower copper content, higher zinc content, it's about 40%, it has a lower extrusion rate. Whereas if you do ever extrude a copper nickel, those are much higher because of the nickel content. So it depends upon the alloy constituents composition as to what the temperatures are for extrusion. Just thought that might be interesting. Obviously for brasses, red brasses, 60-40, 70-30, those are more in the 1200 to 1400 degree temperature range, but they can vary. Well, one of the last things I wanted to talk about in this particular presentation is alloy or issues, other issues. We've talked about this in various ways, various meetings, and I'm sure some of you have talked about these issues in your company with other people, read about them. Okay, there's a new mix of alloys. There are still leaded alloys that are used for a wide variety of things. But for many applications, there's a requirement that low lead alloys are used. What are low lead alloys? Well, there are different definitions for those. For plumbing applications, it's 0.25% lead max. For other applications, it's still higher lead content. How do you handle these? You have to have good labeling, good tracking. Then there's silicon-containing alloys. Then there's a new category of bismuth-containing alloys. Some manufacturers and companies have gone to using bismuth-bearing or containing alloys in place of all leaded alloys. Then there's another issue of once you have scrap coming back, how do you handle this? That's in discussion amongst everyone. We've had those discussions. There's discussions being taken place and continuing to take place within companies at ASTM of how you handle these things, and at various other forums. And then there's problems with alloy compositions. We hear continually that there are issues of material coming in to plants, to facilities that don't meet alloy compositions that are listed, that sometimes are certified to those compositions. That's always a problem. Don't know how to handle that. With this new mix or extended mix of alloys available, we're in a transition time zone when needs to be greater vigilance at what is being produced or provided to you and put into the furnace and returned to the furnace. I don't want to go into it any more, but I just wanted to mention these things. And I think we're about 10 minutes to the hour. And I believe I'm at the point where we could take some questions.
Yes, thank you, Jim. We do have a question that came in. So this person has seen different diameter billets before, but is wondering if all billet lengths are the same.
Well, okay, it depends upon the extrusion machine or a piece of equipment that you're using or the company is using. The billet lengths don't have to be the same. The billet lengths are custom or custom cut for that particular piece of equipment. Some of it has to do with output. Output of the extrusion, you want a certain amount of length. How much material can you get out of the billet? So you have several parameters here. But the biggest thing is the machine parameters. How much of a billet in size, diameter, and length can that machine extrusion press use? You may not want to use the full size if you're producing certain things or certain alloys. That is up to the production manager, production equipment, but there can be different lengths, different diameters, because of different requirements.
Okay. We don't have any other questions in right now. I think, Jim, you're always so good at thoroughly explaining everything. So in the meantime, we'll see if any other questions come in, but just wanted to remind everybody that today registration does close for the Service Center training event at Mueller. It is on Wednesday, September 17th. There's going to be a networking reception the night before. It's going to be, it's very valuable. It's open to CAPSA Service Center members only. And you can find more information on CAPSA's website and to register there. Again, you will receive a survey after the webinar ends. Probably here in about an hour you will get that. It's really brief. It helps us plan future webinars and presentations. Tells us what you want to see. So, and then at the very end of that survey, you will get a link to Jim's slides today. And we'll also have a recording of the webinar as well. I'll probably get that on CAPSA's website today or early next week. And then I'll also send an email out once that is on the website. So, Jim, thank you so much again for being with us. I want to thank our sponsor, ABC Metals. Any final words from you, Jim?
No, this time I believe I am going to be able to be at the Port Huron plant tour, and I'm going to be very interested to see what's going on there, and I would be happy to talk with anybody once we get there.
Great, yeah, that will be definitely a added value to have you there, so we look forward to that. Well, thank you, everyone, and until next time, I guess that's all. So goodbye.